Hello, my name is Gary Swiney, and this is homework 5 for machine learning. In this assignment, we were asked to run the k-means algorithm on the images dataset, describing 5 groupings of images, and determine optimal parameters such as clusters, then generate a silhouette plot and analyze it, and then identify core samples and boundary samples, and then compute the ARI and compare our clustering to the ground truth. So here I wanted to show that our code runs, so I'm just going to run every block that's seen. The first one is just initialization. It's going to take a second to get the images in. Alright, this one is our SSE plot. So after it runs, I can describe it. So in the SSE plot, we're looking for the elbow point. As number of clusters increases, the SSE value will plummet, it'll go down, but we want to maximize our returns. So we're looking for the point with the biggest drop off, and we don't want to capture the diminishing returns afterwards. So I analyzed the pickup and change right here at cluster number 12, and then it sort of starts to flatten out again. So I chose number 12 number of clusters as the optimal parameter, as this baby little elbow joint piece right here. It's a small one. Then we have our silhouette plot. The silhouette plot, because we've selected 12 clusters, the silhouette plot describes the silhouette score for each entry into each cluster. And so what that means is whenever you see these positive values, these are samples in the cluster that are closer to the center of the cluster than any other cluster. And these negative points are points within the cluster that are actually closer to the center of another cluster. So that's what this indicates, is that there's a lot of overlapping in our data set. And despite choosing what seemed to be a good number of clusters for us, we still have a large amount of overlapping that we get to examine later with more plots. So now we get to run our code that identifies core samples, as well as prints the PCA reduced data. So this is going to go through the core samples for each cluster, and we begin to see why there's 12 clusters involved in the code here. It's because there are many types of each type of classification. So here we see a type of plane, we see a type of boat, a barge, we see horses, and one little car snuck in there. We see some cars, we see birds, we see a different type of horse, these are darker horses, we see different types of cars, we see different types of birds, we see different types of boats, these are completely different than the barges before, more different horses, and completely different planes and more different planes than we saw before. So what this is describing is that it's trying to capture all the different types of groupings of each cluster. So for each different type of object in our classification, like we have 3 types of planes or something or other, something like that, we want to have a cluster for each one of those. So we have boundary samples. These are the samples with the 2 lowest silhouette scores. This just says that they're closer to the point of all the samples, they're closest to the point, the center of another sample. So these are the most misclassified samples. We can see this car kind of looks like a boat. Maybe this boat kind of looks like a car. Alright, to answer question number 5, the ARI index, we get a score of 0.433. This is a pretty low score, and what this indicates is that the clustering is okay, but not that good at correlating to the ground truth. And we get to see that here with these graphs. So here's the ground truth graph. We see 1, 2, 3, 4, 5, and tons of overlapping in each of the data sections. So what we're looking for in the clustering is that one or more clusters can describe each ground truth label. So green and beige kind of here sort of explains green here, and then red, green, and blue here sort of explain purple up here, and so on and so forth. You can see these somewhat groupings and the overlappings that go on, and you'll notice that each cluster has about the same radius. That's the idea with clusters. And in terms of the report, that's the same thing. And that explains my homework 5. Thank you so much for listening.